Okay, everyone, welcome back to week 3 of SAT Math. Just getting right into it. Our topic 1 is linear inequalities in 1 or 2 variables. So for our first subtopic, we have create linear inequalities. So we have this scooter rental problem where company A charges $5 plus 20 cents per minute. Scooter B charges $2, but instead it has 33 cents per minute. If m is the number of minutes the scooter is rented, what are the values of m for which company A is less expensive than company B? So we need to convert A and B into equations, as such here. And we're looking for A being less expensive than company B, meaning company B will cost more. So to do that, we set it up as is by just plugging in the equations for A and B, and then we solve for m. So treat this kind of like a equation, except instead of an equal sign, you'll have this A is less than B. So you solve for m, and you'll find that m is greater than 23.1 minutes, which is the correct answer here. And be mindful to switch the sign when you move the variable on the left side. You will have to flip that sign. Okay. For our second subtopic, we have interpret linear inequalities. So we have a system here, and what point is a solution to the given system of inequalities? So in order to find out, we have to, first off, pretty much just plug in points because drawing it out might take too much time. So because two of our options have y as 0, it's good to pick one of those. For time's sake, I'll pick the correct answer, which is 4, 0, which if you plug it in, you'll find that it does work for the top equation. You just plug in 0 for y and 4 for x. And anything, we're just looking for a solution, not what values, to what extent are the solutions. So we're just finding just a single coordinate, which makes our lives much easier. So plugging it in to the second equation, again, 0 into y and 4 into x, you'll find that this also works. This is the correct answer. For our third subunit, we have connect representations of linear inequalities. Okay, we have a restaurant example, and we have a bunch of graphs. So a restaurant plans to purchase X tables, which seats 8 customers, and Y tables, which seats 5. And the maximum number of customers they can fit is 75. So you might be a little confused on how to solve this, especially with all of these graphs looking somewhat similar. So how do you approach this problem? Well, just create the inequality. So the maximum number is 75, meaning we can't go higher than 75. So that is the upper limit, which is why we have this less than and equal to sign. So we have 8x plus 5y. And it is better just to solve for y here because of the graph that we'll plug in. So again, just treat this like an equation, but just keep the sign as is. You solve for y. And essentially, we're looking for the graph with this function. So if you look here, this function here has a y-intercept of 15, and that slope is negative 8 over 5, which works out perfectly, which is option B. Okay, for our last subunit for this topic, interpret system of linear inequalities. So we have a system here, which quadrant has no solutions. So be sure to read the questions carefully. And we find that when you solve, just convert it so it's easier to read. So this top one will just turn into y is greater than or equal to x minus 9. And then we have y is greater than 2x plus 1. So essentially, what we're looking for here is mainly this bottom one, because x minus 9 will cover all 4 quadrants. There's a solution in all 4 quadrants. So what we're mainly looking for is 2x plus 1. So if you look here, 2x plus 1 looks something like this. So you'll find that quadrant 4 has no solutions here. Okay, some solving strategies for linear inequalities. So we have inequality graphing shading, which pretty much just means the way we shade, the correct answers will differ based on the sign. So if you have a less than sign, you'll shade underneath the line. And if you have greater than, you'll shade above the line. And then the equal to sign will make the line solid, and no equal to sign will make it dashed, meaning that dashed line does not contain solutions. And then the second one will be use boundary points to figure out what values actually match the inequality, meaning what is a solution. Okay, so for shading, we have a similar question to the one before. So we again have to graph here. So we have the top function here, y is less than or equal to negative 2 over 5x plus 3. Again, it's less than, so we'll shade underneath the graph. And then same thing, y less than or equal to negative 2x. Now, the strengths of having functions like this is that you don't have to be super exact. We can kind of estimate where these graphs will be because we don't have to be super specific because we're not looking for a specific point, just a quadrant, which makes life a lot easier to figure out where to shade and which quadrant is correct. Okay, now for this one, again, fairly similar to the one before, but we have this problem here. If we have a second linear inequality, which of the ordered pairs is a solution? So this time we have to be a little bit more mindful of where we're looking at. So we need an area that covers both graphs. So we have y is less than 3x plus 7, which is this line here. Because we're looking for a specific coordinate, we will have to be a little bit more specific and draw the correct line. So if you look here, anything under this blue line will be correct, but again, we're matching it for both lines. So we need the area that is shaded by the given line and this blue line. So specifically, it's more so this area here, which if you look closely, the correct answer will be negative 1, 2. Okay, for our second topic, we have equivalent expressions, which can get fairly tricky, especially if you guys aren't familiar with your math. And then we have this question here, which is fairly difficult. We have a solution for, or we have to find a solution for 6x squared y plus 8xy squared equals 6x squared plus 8xy. And we need to find the solution here if x does not equal 0, y does not equal 0, or plus or minus 1. So that pretty much just means y cannot be positive 1 or negative 1. And we have to find the value in terms of y over x. Okay, so if you don't know how to start, just try and simplify it the best you can, because then you can make an educated guess rather than guessing blindly. So we set up our equation. So we're trying to look to factor out anything possible. Now, factoring gets easier if we align the 6's and the 8's, so that's what we'll do. We'll subtract 6x squared from the right side to the left, and then we'll subtract 8xy squared from left to the right. Okay, because our y's here, when we factor out 6x squared on the left side and 8xy on the right side don't match, we can multiply the right side by negative 1 to flip that 1 minus y to y minus 1 and have there be that negative 8xy in front instead of the positive. Now, once you get to this point, remember x cannot be 0 and y cannot be positive 1. So we can kind of just disregard it because it's the same. We can just divide them out. And because x cannot equal 0, we can factor out the x from both sides. So we'll be left with 6x equals negative y. And in terms of y over x, that will be negative 6 over 8 or negative 3 over 4. Okay. For our second subunit, we have operations with polynomials. So this is just a longer FOIL, essentially, and you guys might get confused, which is why I decided to pick this problem. So when you start off here, I would pick the two that would make life the simplest. Sometimes there are terms where you just have to do a 3-term polynomial multiplied by a 2-term polynomial. But in this case, we can actually keep it 2 terms. So x plus 3 times x minus 3 will actually, once you FOIL it out, which stands for first, outside, inside, last, will turn into x squared minus 9. So that stays 2 terms and makes it very easy to solve, which is why we can do it in this way. Instead of multiplying 3 cubed plus 9x times either x plus 3 or x minus 3, life is just easier this way. So I would recommend solving it this way. If it doesn't matter to you, you can solve it however way you want. But in this case, you FOIL it out as normal, and you'll end up with x to the 5th minus 81x. Okay, so a solving strategy I have for solving polynomials is the use of distributive property. If you're not familiar with FOIL or it can get complicated, understanding how distributive property can play into polynomials can really help you. And I'll explain here. We have this 3-term polynomial times a 2-term polynomial, so we can't just FOIL like normal. So because that can get a little frustrating, what we can do is that we can just use the distributive property and just solve it like this, where we just multiply each term by the from the 2-term polynomial by the 3-term polynomial like this, and it can make it a lot simpler to solve. So once you simplify everything, you get x cubed plus 4x squared minus 5x minus x squared minus 4x plus 5. So once you add everything up, you get x cubed plus 3x squared minus 9x plus 5. So that's it for the week 3 lecture, a bit shorter than usual. And again, if you liked the video, please like and subscribe.